In this question, the moment of inertia of the uniform cylinder, जिसका लेंथ L है, रेडियस कैपिटल R है, and perpendicular bisector के along moment of inertia suppose I है, and what is the value of the minimum value of the L by R? What is the ratio of the L by R? So the moment of inertia will be minimum. Then suppose that this uniform cylinder, solid cylinder, whose length is a capital L and the radius is a capital R. Then according perpendicular bisector, the moment of inertia is equal to, according rod, that is ml square by 12. According dia of the disc, it is mr square by 4. Then we know mass of the cylinder is a constant, therefore the volume is constant, and volume is equal to pi r square is the area into length. If we eliminate the radius in terms of volume and length, then the whole I is in terms of the length. So it is ml square by 12 plus m by 4 and the radius ka square. Radius square is a volume upon pi L. Now this I is a function of L. So at the particular length, di by dl will be 0 and I will be minimum. So di by dl is a mass into L square का 12 means ml by 6 and it is a mv upon 4 pi. L to the power minus 1 का minus L to the power minus 2 means 1 upon L square. If we put the value of the ml by 6 minus mv by 4 pi L square equal to 0 means both are equal. M से M cancel कर दें. Then it is L by 6 equal to pi r square length upon 4 pi L square. If we cancel with the L, pi with the pi, then it is L square by r square equal to 6 by 4 means 3 by 2. Therefore L by r equal to, that is the ratio of the length to r is equal to root 3 by 2, and I think root 3 by 2 means third option is correct. The question is square sheet of the length L. Therefore the length of the sheet is L. It is a square in the shape. Now it becomes a cylinder. It is a hollow cylinder. It means इसको hollow cylinder बनाएंगे. Then what is the radius? We know the 2 pi r, radius is equal to the length of the side of the square, and the height of this cylinder is also L, and the radius is equal to L upon 2 pi. Now we want to find the moment of inertia about the central axis, about this axis के about निकालना है. Then it behaves like a ring, and according ring moment of inertia is I equal to m r square, and the I equal to mass into radius. Radius is equal to L upon 2 pi. Therefore radius is का square equal to L square upon 4 pi square. And we know mass equal to, what is the area? Area is a L square. Therefore the area is multiplied by the surface mass density is given. So the mass per unit area is a rho. So mass is equal to area into rho. So it is a rho into area. Area means it is a power 4. So moment of inertia is a density into L to the power 4 upon 4 pi square. So according this one is a correct option is a third one. According this problem, the smooth inclined plane, there is a smooth inclined plane of inclination theta. A sphere is set in a pure rolling on the incline. For what value of the theta, the acceleration of the car in the horizontal direction, that means it is inside the car, and the inclined plane का angle of inclination जो कि दे रखा है, that is theta. If this is a rolls on the inclined plane and that is a smooth होने का meaning there is a force, there is no force along the inclined plane, this is a accelerate in the horizontal direction, the acceleration is a, then the pseudo force on this is a ma, and the weight is a mg. If along the plane net force equal to 0, then it will pure roll without any slipping. So what is the component along the plane? That is a ma. This angle is a theta, so it is ma cos theta. If the ma cos theta and the component of the weight, it is a mg sin theta. If both balances each other, therefore the net force along the plane will be 0. So we can say ma cos theta is equal to mg sin theta. Then acceleration of the is equal to g tan theta. If the acceleration is g tan theta, that means it pure rolls without slipping. So g tan theta is a correct option. So the fourth one is a correct. In the given situation, a uniform sphere, hollow sphere, no? It is a hollow, smooth uniform sphere of mass small m rolls without slipping on a smooth horizontal surface. That means suppose the A is a given, B is a given, A and B both are identical, same mass, same radius. Now this A is a rolls without slipping. It means its velocity is a v and the angular velocity is omega. That is a velocity is 0 and omega is also 0. Now this collision is elastically, it collides head-on elastically. It means what is the kinetic energy? That is a rotational and translatory both are present. Translatory kinetic energy is suppose half mv square. Then rotational kinetic energy is half I omega square, and I is a 2 by 3 mr square. Therefore that is 2 by 3 times of the half mv square. Now when this A collides head-on with the B, then omega will present in the A, but the velocity completely momentum transfer to the second body. Then we can say the kinetic energy just after the collision, kinetic energy of the B is a half mv square. Then the kinetic energy of the A is a half I omega square, means half mv square, that 2 by 3 times. And ratio किसका पूछा? The ratio of the kinetic energy of the B, this to this, 1 upon 2 by 3. So it is 3:2. Correct option is a third. Given the wire of the length L, wire का length L है, mass is small m. It is bent in the shape of the rectangle, and the side of the rectangle AB to BC is a 2. That means suppose the AB, this is a AB and that is a BC. Then this rectangle ABCD and again A, the total mass is m. So this part of the mass is m by 3 because the length is a L by 3. This part is m by 3, length is L by 3. This part is mass of the m by 6 and the length is L by 6, m by 6 and L by 6. And here we want to find the moment of inertia of the side about BC. BC की about find करना है. Then we know BC along BC is a, खुद BC का 0 हो जाएगा. And these are the all particle which are distance of the L by 3 and the masses of the particle is m by 6. So m by 6 multiplied by L square by 9. दोनों rod के end के about, so it is a mass is m by 3. So it is a 1 by 3 of 2 because the mass into length square by 3 is the moment of inertia of the rod about its end, and the length is L by 3, so L by 3 ka square L square by 9. That is the total moment of inertia about BC. And about BC is it is I think ml square by 27 common ले लें. Then it is a 1 by 2 plus 2 by 3. Then it is ml square by 27 multiply by, it is 6 and it is 7. So IBC is a 7 ml square. Divide by 27 into 6. It is a 2 and 4 is a carry. It is 16, 162. So correct option is a fourth one.